In part E of example 1.17, we have h of t equals t divided by the square root of t plus 1. Let's take a look at the operations that are here. There is an addition, there is a square root, and there is also a division. Now, out of those three operations, we know that two of them are of concern, the square root and the division. So we're going to need to analyze these two ideas separately and then check the results and then merge the results together as one, because there can only be one domain for this function. So let's start with the division. So with the division, we are dividing by the entire denominator there, square root of t plus 1. So algebraically, we are expected to take the square root of t plus 1 and set it equal to 0. Now we have to solve this equation. So we go back and think about all the solving techniques that we learned in a pre-algebra course, and we would square both sides to get t plus 1 is equal to 0, and then subtract 1 from both sides, and I would get t is equal to negative 1. Remember, when you are doing your division analysis, this represents a restriction. This is not a value that we want to include in the domain. It is a domain restriction. Now let's go over to the square root. For your square root, you're taking the square root of t plus 1. So we're supposed to take the t plus 1 and make it greater than or equal to 0. Solving that, I'm just going to subtract 1 from both sides, and I will get t is greater than or equal to negative 1. So from that number line perspective, that is saying that I want a closed boundary at negative 1, and then I want everything to the right. So there is a little bit of a contradiction here. Over here on the right, this is saying include negative 1. But certainly over here on the left, we have a domain restriction which says to exclude negative 1. Now, if one part of the equation says to include and the other part says to exclude, then we have to go with the most restrictive idea, and that would be to exclude. So when you have a little bit of a conflict of interest here, so to speak, you have to go with the exclusion. You will not be able to include negative 1, you'll have to exclude it. So rather than writing this with a hard bracket, we'll write it with a soft bracket or a parenthesis. So the domain of h will be open at negative 1 to positive infinity, rather than having a hard bracket there. So there's your domain for h. It combines both the division and the square root concepts. And now we would write our function definition, h, domain negative 1 to infinity. Those are the numbers that map to real numbers, given by h of x is equal, not h of x, h of t. H of t is equal to t divided by the square root of t plus 1.